Chapter 4.7 Relating a Uniform Series Annuity to its present and future equivalent values. So, bago tayo mag-discuss about this, bakit nga ba mahalaga yung diagrams for us or for engineers? It's because diagrams help us understand concepts faster and better by providing a tool to visualize the concept. So, when we're talking about finances, like we do in engineering economics, it is not uncommon for us to use some kind of diagram that represent the flows of money, flows of cash that happen in the process of something or some sort of a project. Next, what is annuity? An annuity is a series of equal payments made at the ends of equal intervals of regular time periods for a fixed duration. Each amount A occurring at the end of each period for n periods with interest at 1% per period. The time periods could be weekly, monthly, quarterly, yearly, or at any other time interval. As you can see, we have a diagram here. So, first of all, we represent time with a horizontal line. Ito, the horizontal line. So, now, we represent that as time 0, as time 0, and then maybe as time goes on, this can be years, month, days, or also a period. This 1, 2, 3, 4, and so on and so on. So, on a timeline like this, we can represent the flows of money either to you or from your with arrows. With arrows in this diagram here. May mga arrow. So, we have a particular direction that we show here. So, if you show an arrow instant up, so kung may makita tayong ganito, arrow na pa-up, this arrow na pa-up it means like this is a positive flow. You gained money, a cash flow in. So, this idea of a cash flow diagram that you have a timeline and over the timeline you show arrow up being cash inflows. Ito siya. Then, arrows down, ibig sabihin is when arrows down, it is being cash flows out. So, these cash flow diagrams that we are talking about, one quick thing to mention here is that when we are using cash flow diagrams, if the storage techniques for resources involves interest, then you put resources into an account and then you take them out later, those two values are going to be different from one another. So, let's say we have this timeline. We have this timeline here. These two timeline. And then, what happened here is you are going to put resources into an account, which basically means we have to pay in the account, which means it's coming out of your own resources. And then, after having stored those resources in the account for a specified number of periods, then you get to take some out. So, the idea here is that this was P. We say P is, and this F. So, being present and future values. A present and a future values. So, how do I know how much future value I get out of the account? So, the interest formula that would be F is equal to P 1 plus I raised to the power of n. So, F here is the future equivalent values and then the present values. Then, 1 plus the interest rate, and n. As I said earlier, diagrams help us understand concepts faster and better by providing tool to visualize the concept. Engineers like diagrams because they help them visualize concepts. So table notation. P, present equivalent value, occurs one interest period before the first A uniform amount. F, the future equivalent value, occurs at the same time as the last A and N periods after P. And last, the A, annual equivalent value, occurs at the end of periods 1 through N inclusive. So what if we already know the amount of F? Then I wanted at the end of this period, let's say, my question is, I want to have a specified amount of future value and I want to know how much present value I should put in right now to get that future value. So we have a way to manipulate this formula. The easiest way to do is just divide both sides by 1 plus the interest rate raised to the power of n. 1 plus 1 plus the interest rate power of n. We have present value equal to future equivalent value 1 plus the interest rate negative n. So this is by the rules of exponent. So example, right when you get out of college, you sign on with a company for your first job. That company gives you a $15,000 signing bonus since you do not plan on starting a family for 4 more years. So you decide to keep that bonus in an account earning 6% per year compounded quarterly to go toward the down payment on a home purchase. So, question letter A, what will the account be worth for 4 years from now? So, how do we do that? So, first of all, actually, let's draw a cash flow diagram. Yung cash flow diagram natin. That actually what we are saying there. So, we are going to assume here, as makikita natin, na it's compounded quarterly. So, that means we need to look at quarters. What does mean? So, there's 4 quarters in a year. So, there's basically 3 months. That's not an uncommon unit of a time to use in a certain areas of investing. So, we're gonna compound it quarterly and we're going to do what here? So, we have $15,000 here. What we do is, we put in the bank, which means it goes out of our pocket. So, that's $15,000 for us. We wait for a specified number of periods being years, so we have 0. So we have one year, 2, 3, and 4. So now what happens in year 4? So basically this is a future value, right? So as we can see, it would be back into your pocket then from it going making a down payment on a home. Or the question is, what is the value? What will be the account or 4 years from now, and what is the value? So the formula, we're basically finding a future value from the present value. So F is equal to $1,500. 1 plus 0.06 over 4 raised to 4 times 4. So it is equal to $19,034.78. Question letter B. If you want to wait until you have accumulated the balance of $21,000, how long would you wait before making the home purchase? So here we know that the future value needs to be $21,000. So we know that the present value is $15,000. And we have 1 plus the interest rate, the 0.06 over 4, raised to the power of 4 times n. So the interest rate doesn't change, nor does how many times we compound it. What does change is 4 times n. So we're trying to solve for n, so the answer is 5.65 years. Letter C. If you want to keep the plan of making the home purchase in 4 years and you want $21,000 at the time, how much would you have to supplement the $15,000 bonus to deposit now? So solve for P. We could say P is equal to F. So 1 plus 0.06 over 4. So the interest rate over the number of times per period that you compound raised to the negative 4 times 4. So because we swap around the direction of the calculation, P is equal to $16,548.65. But the question is, how much would you have to supplement? You have $15,000 from bonus, so how much would you have to add to that? Make sure you get to this end. So what we'll do, take the value and subtract, and what you get from bonus, so it is equal to 1,548.65. Summary of interest formulas and relationship for discrete compounding. So, what is discrete compounding? It means that the interest is compounded at the end of each finite length period, such as month or year. So, table 4.3, as you can see, it provides a summary of the 6 most common discrete compound interest factors. It's utilizing notation of the preceding sections. So the formulas are for discrete compounding, which means that the interest is compounded at the end of each finite length period, such as month or year. Furthermore, the formulas assume discrete, or example, lump sum, the cash flow space at the end of equal time intervals in a cash flow diagram. So discrete compound interest factors are given in Appendix C, where the assumption is made that one remains constant during an compounding periods. There are also several useful relationships between the compound interest factors. So these relationships are summarized in the following equations. So P over F, the present equivalent value over the future equivalent value, the interest rate, and N is equal to 1 over F over P, interest rate M. So another, A over P, I, N is equal to 1 over P over A, I, and N. So another, 4.18, A over F, the interest rate, N is equal to 1 over F over A, interest rate M. Another, F over A, the interest rate, N is equal to P over A, the interest rate, N, times the F over P, interest rate, M. In 420, P over A, interest rate, N is equal to the summation of N, K is equal to 1. So P over F times, P over F, the interest rate, K. So here, F over A, interest rate, N is equal to F over P, interest rate, N minus K. A over F, interest rate, N is equal to A over P, interest rate, N minus I. As we can see the table 4.3, we have for single cash flows, we have the F and P. So P and F, so 1 plus I to the power of M. So factor name, it is a single payment compound amount. So itong pangalawa, this is 1 over 1 plus the interest rate raised to N. It is a single payment present worth. Yung una is a single payment compound amount. So for uniform series, we have the F and A, 1 plus the interest rate raised to N minus 1 over 1. It is a uniform series compound amount. So, here, 1 plus the interest rate raised to n minus 1 over the interest rate times 1 plus interest rate to raise of n. So, this is the uniform series present worth here. So, this is the sinking fund or the interest rate over 1 plus interest rate raised to n minus 1. So, here. Next, the A and P, interest rate times 1 plus interest rate raised to n over 1 plus interest rate raised to n minus 1. It is a capital recovery. So I is equal to effective interest rate per interest period, and n is the number of interest periods. A is a uniform series amount occurs at the end of each times of each interest period. So F is a future equivalent and P is the present equivalent. Point 9, deferred annuities uniform series. So from the word deferred annuity, it is the type of annuity where the payments are deferred for several periods of time. So from the word itself, it is pinagliban muna yung ilang period ng paghuhulog, unlike kapag ordinary annuity na nagsisimula yung payment sa end of period of a first period. So, this time, kapag deferred, hindi ka magsa-start sa beginning or end nung first period. But other period, pwedeng after 2 years, 3 years, depende sa kondisyon. So, itong deferred formula na ito ay nakabase rin sa ordinary annuity. So here, to derive natin yung formula for deferred annuity, mostly, ang pinakahanapan natin dito ay ang present worth ng deferred annuity. So, di ba, deferred siya. So, for certain periods, let's say, sa cash flow diagram natin, na deferred yung payment, escape at period K. So, lumipas muna yung period K bago siya nag-start magbayad nung mga annuity. So, like ganito, yung mga binayad niya. Then, the certain interest dito na, meron din tayong certain interest dito na, interest rate. So, ngayon, paano natin ma-derive yung present worth ng deferred annuity? So, ang gagawin natin ay, ang lahat ng A, lahat ng annual payment, annuity payment is like an ordinary annuity, diba? So, this time, from period K to N, is, this time, kailangan nating ibalik dito sa K1. Ito yung K1. So, diba yung hanapin natin yung present worth? So, ang total date natin ay 0. So, lahat ng mga nahulog niya from K to N is ibabalik natin papunta sa period 0 here. So sum up lang natin yung lahat ng annuity payment, yung A, sum up lang natin. So, ang formula niyan, so, ito yung formula for a present worth of deferred annuity where the payment is deferred for K period. Ito na po yung mga formula niya. So, P prime is equal to A over interest rate, 1 minus quantity of 1 plus interest rate raised to the negative n. So, 1 plus interest rate to the power of negative K minus 1. So, the future equivalent value here is F is equal to A over interest rate times 1 plus interest rate raised to the power of n minus 1. So, ito na yung formula. Determine the present worth of a deferred annuity consisting of 10 semi-annual payments. Each 1,000 is the first at the end of the third year. So, money is worth 14% compounded semi-annually. So, isulat natin yung given. So, ang gagawin natin ay, yung payment ay 10 semi-annual payment. So, ito yung N natin. So, here. Ito yung N natin. This time, hindi years ang binigay, kundi yung semi-annual payments lang. So, ibig sabihin, naka times 2 na yan. So, yung 1,000 is, siya yung A, yung babayaran niya every semi-annually. Tapos, magsa-start siya magbabayad at the end of the third year. So, ito yung K natin. Then, R, the 14%, and the M is 2 kasi semi-annual siya. So, ngayon, sa cash flow diagram, nag-start siya na naghulog sa third year. Dito siya. Nag-start siya nahulog sa third year. Here. Third year. So, naghulog siya ng third year. Tapos, ang hulog niya sa semi-annual. So, bawat isang taon, hatiin sa dalawa. So, kaya ganito. 1, then 2, ito yung 3, then 4, hanggang, So, pag 10 semi-annual corresponding yan sa 1 year, so therefore, hanggang 8 years siya magbabayad. Hanggang 8 years magbabayad. Now, starting from 3 to 8 years, is, i-apply natin yung formula na A, 1 minus times 1 plus the 0.14, yung R natin. So, raised to negative 10. So, ibabalik po natin ito sa 0 periods. Kailangan natin ibalik sa 0 period. So, magbabalik tayo ng semi-annual. So, here, R is equal to 14%. So, I is equal to R over M is equal to 14% over 2. P is equal to 1,000 pesos. 1 minus times 1 plus 0.14 yung R natin over 2 minus 10 over 0.14 over 2. So, 1 plus 0.14 over 2 raised to negative 5. Yung sagot natin dito ay ito na. Sagot natin is 5,007.72 pesos. Examples, as you can see, 4.32. An outright purchase of $20,000. Now, a lump sum payment can be traded for 24 equal payments of $941.47 per month, starting 1 month from now. What is the monthly interest rate that establishes equivalence between these two payments plans? So, given P is equal to $20,000, A is equal to 941.47, and is equal to 24. So, at Appendix C, the interest rate is equal to 1%. So, P over A, interest rate, and the N is 24. So, solution. P over A, interest rate, and N, which is 24, present worth factor. So, 20,000 is equal to 941.47. Quantity P over A, interest rate, 24. So, 2,434 is equal to 21,2434 is equal to quantity of P over A, interest rate, and the N is 24. So, for capital recovery factor, 941.47 is equal to 20,000. So, quantity A over P, interest rate, and the N is 24. So, 0.0471 is equal to A over P. Interest rate, and the N is 24. So, quantity A over P, interest rate, N. So, at the table C.4 in Appendix C, we can see that the interest rate is equal to 1%. So, therefore, the answer is 1%. So, 4.35. Spivey just won the Powerball lottery. So, the $20 million jackpot will be paid in 20 annual installments of $1 million each, with the first payment to be paid immediately. Spivey's opportunity cost of capital interest rate is 6% per year. What is the present equivalent of Spivey's lottery winnings at the time of the first payment? So, given A is equal to $1 million and is equal to 20 minus 1, so it is equal to 19. And the interest rate is 6%, so solution. P is equal to A plus A, 1 plus the interest rate raised to n minus 1 over interest rate times 1 plus interest rate raised to n. So, $1 million plus $1 million, which is the A plus A, times P times A, 6%, which is the interest rate, and the N, 19. So, it is equal to $1 million plus $1 million times quantity 1 plus 0.06 raised to 19 minus 1. So, over 0.061 plus 0.0619 raised to 19. So, it is equal to $1 million plus 11,158,116.49. So it is equal to $12,158,116.49. Therefore, the present value of a lottery winning is $12,158,116.49. So 4.52. You have just inherited $100,000 as a lump sum amount from your distant aunt. After disposing that money in a practically risk-free certificate of deposit earning 5% per year, you plan to withdraw $10,000 per year for your living expenses. How many years will your $100,000 last in the view of these withdrawals? So, given A is equal to $10,000, rate is equal to 5%, P is equal to $100,000, and we find N. So, solution. P is equal to A, quantity 1 minus 1 plus R raised to negative N over R. So, 100,000 is equal to 100,000, quantity 1 minus 1, 0.05 raised to N over 0.05. So, 100,000 times 0.05 over 10,000 is equal to 1 minus quantity 1.05 negative n raised to negative n. So 1.05 raised to negative n is equal to 1 minus 1 half. So 1 minus 1 half is equal to 1 half. So n is equal to 14.21. Therefore, it can be able to withdraw $10,000 on $10,000 till 14 years, but you need is 15 years to completely deposit. 4.54. Chris borrows some money in her senior year to buy a new car. The car dealership allows her to defer payments for 12 months, and Chris makes 48 end-of-month payments thereafter. If the original note loan is $28,000 and interest in 0.5% per month on the unpaid balance, how much will Chris' payment be? So, problem 4.54. Given is P original amount is equal to $28,000 and the interest rate of 0.5% per month. So, solution. FR is equal to $28,000, quantity F over P 0.5%, the interest rate, and the N is 12. So, it is equal to $28,000, quantity 1.06167. So, FR is equal to $29,726.76. So, A is equal to FR, quantity A over P, the interest rate of 0.5 interest, and 48. So, it is equal to $29,726.76, quantity 0.0235 or times 0.0235. So, A is equal to 698.57886 or $698.60. So, Therefore, Krish will be paying an amount of $698.60 per month.